In this lesson, we will cover single sign-on. Single sign-on, also known as SSO, is an authentication process that allows a user to access multiple applications or websites by logging in only once with a single setup, such as by using a username and password. This approach simplifies the user experience and increases productivity by reducing the need for users to remember multiple passwords across various websites and applications. So, how does this SSO work? Well, single sign-on works based on a trusted relationship that is established between an application and an identity provider, also known as an IDP. The identity provider is a system that creates, maintains, and manages identity information for principals while providing authentication services to relying applications within a federation or distributed network. Now let's take a quick look at the simplified step-by-step process used by SSO. Most commonly, SSO is used inside of an enterprise network and relies on the trusted relationship between your Active Directory controller and your various applications and websites that are part of the organization's network. First, the user logs into the primary identity provider, such as your Windows domain controller, who most commonly accepts their username and password as their method for authentication, or the use of a username and password with a one-time code, making them more similar to multi-factor authentication systems. Then, the user attempts to access a secondary application or website that is configured to use SSO and has a trusted relationship with the primary identity provider. For example, if you are trying to access your organization's internal SharePoint server, it might not ask you to submit for your username and password a second time because you have already been authenticated by the primary identity provider, your Windows domain controller, and therefore the secondary application or website, in this case the internal SharePoint server, will send a request to the primary identity provider to verify the user's identity, and the primary identity provider will then respond back with their assertion that the user is authenticated. At this point, the secondary application or website grants access to the user, and in this case, you are now logged into the SharePoint server and can continue to perform your required work role for the day. There are several benefits to using single sign-on, including an improved user experience, increased productivity, reduced information technology support costs, and enhanced security. First, we can create an improved user experience. Since users will only need to remember one set of credentials, this can reduce their frustrations of forgetting their usernames or passwords for websites and applications that they don't commonly use. Second, we have increased productivity. Since users can save time by not having to sign in each application separately, they can get more work done in less time, which increases their productivity on their job. Third, we have the reduced information technology support costs. One of the largest and more time-consuming requests that most server desks receive is to reset a user's password when they forgot it. Since SSO has less passwords that you need to memorize, this creates fewer password reset requests so that the help desk workload can be significantly reduced. Fourth, we have enhanced security. It may seem counterintuitive at first, but single sign-on can actually improve security by encouraging the use of stronger passwords, since your users only have to remember a single password, and this also helps to reduce the risk of password reuse. Now, many of us already use single sign-on on a daily basis without realizing it. For example, if you try to log into diontraining.com and you use your Google account to do that, you're actually using single sign-on in our federated system where Google is authenticating you, and then you log into our website as well, since we have a trusted relationship set up within their system. Another example that is used in the corporate world, where a company might set up a SSO for their internal applications. An employee logs in once into their company credentials and then has access to their email, project management tool, and HR system without needing to log into each one separately. To enable and support single sign-on, there are three commonly used protocols: LDAP, OAuth, and SAML. First, we have LDAP. The Lightweight Directory Access Protocol, or LDAP, is a protocol used to access and maintain distributed directory information services over an internet protocol network. LDAP can be used to look up encryption certificates, connect to printers and other services on the network, and provide a single sign-on capability where one password for a user is shared between many different services on the network. Lightweight Directory Access Protocol, as the name implies, is often used as a directory service to essentially share the information infrastructure for locating, managing, administering, and organizing common items and network resources. These resources can include volumes, folders, files, printers, users, groups, devices, and other objects in your enterprise network. For example, an organization may use LDAP to form a directory of its employees that allows information about those users to be stored in one place and accessed by different applications, including your contact list, address books, and email clients. The Lightweight Directory Access Protocol is also used in authentication and serves as a central repository for user information. When a user attempts to log into a system, the system can query the LDAP directory to check the entered username and password. If the LDAP directory confirms the credentials, the user is authenticated and granted access. LDAP can also store other user information that can be used for authorization, such as what groups the user is a member of or what roles that they have. This allows systems to make decisions about what resources or services a user should have access to. While LDAP can transmit data in plain text, it also supports a secure version known as LDAP-X, which can support LDAP over SSL or Start TLS, both of which encrypt the data to provide secure transmission. This is particularly important when transmitting sensitive data such as user credentials over a semi-trusted or untrusted network. Now, second, we have OAuth. Open Authorization, or OAuth, is an open standard for token-based authentication and authorization that allows an individual's account information to be used by third-party services without exposing the user's password. For example, when you log into a website like DeonTrainer.com and it offers one or more options to log in using another website or service's credentials, that is actually OAuth at work behind the scenes to allow that login process to occur. The OAuth protocol is commonly used for authentication and authorization in RESTful APIs since it is designed to allow secure sharing of user profile information between sites. Users create an account with the identity provider, and then they can use this account to log into another OAuth website without sharing their password with that specific website. When using this setup, a user can grant a client like an application or website authorization to access parts of their accounts like their name, email address, profile picture, and other details. The user account is hosted by one or more resource servers, also known as API servers. Authorization requests are processed by an authorization server, which can manage multiple resource servers. The client application or service must be registered with an authorization server and provide a redirect URL and receives an ID and a secret. When the client requests authorization, the user approves the request, and depending on the flow type, and then the client receives an access validation token by the authorization server. This token is presented to the resource server to access the requested resource. To transfer this claim data over the network, the OAuth protocol uses the JavaScript object notation or JSON formatted web tokens known as JWT, which can be easily passed in a base64 encoded string in URLs and HTTP headers and can be digitally signed for authentication and integrity. Third, we have SAML. The Security Assertion Markup Language, or SAML, is a standard for logging users into applications based on their sessions in other contexts. Now, this single sign-in logon standard has significant advantages over logging in using a username and password though. When a user logs in using SAML, rather than asking for a password, the application redirects the user to an identity provider with a SAML request. The identity provider then verifies the user's identity and sends a response back to the application, which in turn logs the user into the application or website. Now, SAML can be a little complex, but what you really need to remember is that it enables services to be decoupled from the identity providers and eliminates the need for services to authenticate users directly. Instead of the service provider conducting the authentication, the service provider just receives confirmation from the identity provider that the user has been authenticated into the given service. So remember, single sign-on, also known as SSO, allows a user to access multiple applications or websites by logging in only once with a single set of credentials. LDAP is a protocol used to access and maintain distributed directory information services over an IP network. OAuth is an open standard for token-based authentication and authorization. SAML is a standard for logging users into application based on their sessions in another context. Single sign-on is a great technology that increases usability and increases the security of your authentication systems by relying on a network of trusted identity partners to help ensure that each use is properly validated and authenticated.